So the problem, first problem I wanted to do as a warm up is kind of just basically you're going to be given, you know, a binary tree, a binary search tree,
Okay.
correction, uh, a root as well as two other nodes, and you want to find the lowest common ancestor of those two given nodes. So I can
Okay.
paste in the actual question, but that's just kind of the overview.
Okay. So I have done this question, and essentially what at least what I do is I find the path from that root to the P, and I kind of like push it sort of like on the stack, and then
Okay.
pardon?
Okay.
Yeah, so essentially what I do is I find the path till 2, so it's like 6 and 2, and then I find the path till Q, which is 6 to 8, right? And then I basically go from 6 to like till wherever it matches, I go there, and then I say, okay, this is the common ancestor, essentially.
Okay, so that does sound like a solution for a binary tree, but I think when we have a binary search tree, we can do a bit better
Oh, yes, yes, yes.
than that.
Sorry. Yeah,
Have
I'm so
you
sorry.
also done this problem?
Pardon?
So you've done both variants, or have
I
you
have
just
I
done the
have done.
binary tree version?
No, no, I've done both variants, right? Essentially, so the only thing with BST is that depending on the value, you're gonna go left or right, right? That's so
Right.
that way is rather than going through the whole tree, right?
Yep.
Using big of n, instead of that, you will be doing all of that in log n, essentially,
Gotcha.
right?
Because you're just doing it based on, yeah, like you said, based on the values,
You
like
can go
left and
left or
right
right,
hand. Yeah,
essentially.
I think both of those roughly sound there, so we can change the problem.
Oh, okay.
Um, so this one I don't have something to formally paste in, and I can, I guess, just describe it. So for this
Sure.
problem, what you're going to be given is a 2D matrix, right?
Okay.
And what you should have is a series of zeros, negative ones, and you'll have a bunch of negative twos,
Okay.
right? And what you want to do is go through and fill the entire matrix such
Mhm.
that all of the zeros are updated so that they instead contain the distance, the shortest distance to the nearest negative one value. So let's pretend that the negative ones are guards and
Okay.
the negative twos are walls. So you want to
Okay.
find the shortest distance to a guard, and the only condition for when you're moving around is obviously you can't
Go
move
through the wall.
over
Yeah.
and you can't go through the walls. Yeah. So is this question also one you've done?
So I don't think I've done this question. I've done other matrix questions, but this is not the one that I've done. So
Gotcha.
let me think about this, right? So essentially, you're saying that let's say you will give me an INJ, right, which will be sort of like my starting position.
Oh, there's no starting position. So you're just updating this entire thing so that it has the shortest distance to every gate. So in this example, you have 1, 1, so you'd have 2 here, 3 here. Does that kind of
Okay,
make
so
sense?
yeah, just give me 1 second, right? I'm trying to understand this. Sorry. So essentially, so let's say I go to 0, right, the first element, and
Mm-hmm.
then I find, okay, -1 is the next element to me,
Yeah.
right? So -1 is sort of like the value that I'm looking for,
Yeah.
essentially, right? So here you will say, okay, I'm 1 away from a -1, right? And then you will go here, and then you will be like, okay, I'm 1 away from a -1, right? And here you
Okay.
will go, and here, why are you saying that you're 2 away from a -1? Because
Uh,
you,
you're two
oh,
distance
I see.
away, right? It takes
Yeah,
you
yeah,
two
yeah.
steps
I
to
see,
get
I see.
to a -1.
I see. Okay. And we are only looking at the vertical and the horizontal, right? You are not looking at diagonal, or are we?
You're not looking at diagonal now.
Okay.
Because if you can
So
move diagonal, then the one at the I guess the bottom one would still be yeah, there's
you
no
want,
diagonal.
right? Okay, there is no diagonal, right? So, okay, I see your point. So essentially, the overall idea is that for each element which is 0, right? What you do is you try to find out where exactly in the vertical or horizontal is there a -1, right? And essentially for each element you try to find, okay, where is a -1, right? And the moment you hit a -1, basically the minimum of the -1s that you hit in
Yeah.
each in each of the left or right, vertical or horizontal, then you
Yep.
return back that value,
Right.
right? And
So
if you hit go ahead.
yeah, you can go ahead. I think you're still talking about your approach.
Yeah. So I was just thinking that if you hit a -2, then you would basically just go back. Like you'll just return. You'll be like, okay, you know what? I can't go here, so I'm just gonna return essentially, and then I'm gonna go wherever I was going.
Right.
Right. I see. Okay. Okay. Mm, okay. So the way I'm thinking about this is, so overall, my pseudocode is gonna look like. So I'm gonna go from I to n, right, and then I'm gonna go from j to m basically,
Right.
right, assuming it's n by m. And then I'm gonna write a function which essentially would be like if a of I of j, if this essentially is gonna be 0, then I'm gonna call my find max distance,
Right.
right?
Or the min distance. Okay. So I think I have the general idea of the approach that you want to take here.
Uh-huh.
Is there any way that we can improve this? Because it seems like you're starting from the 0 and then you're searching for a 1, right? And you're going to repeat that for every 0. But that's pretty expensive to do.
Yeah. For
And it
each
seems like
time
you're
you're
repeating
gonna.
operations.
I see your point. Yeah. No, I see your point. mm, what can I do? Hmm, Let's think about this. So this is an array. Um, so I would, okay. So what I can do is maybe do something like a DP kind of a thingy, right? Where
Okay.
essentially what I do is, for each of these elements, I'm gonna look one ahead and try to find out where exactly is like sort of like the -1, just one ahead,
Okay.
right? So I will look at like, so let me just go back here, right? So here, for example, from 0 I will look ahead, and I will look left and I'll look at bottom, and I'll say, okay, I found the -1 at 1, right? And then you will basically, for -1, you're not gonna do anything, right? You essentially, mm, so essentially what I'm trying to do is, for each of these elements, I'm gonna find out what is whether I can find a -1 distance in one step, right?
Okay.
And essentially, okay, let me try to think. Once I do that, then that way I can identify how, by looking at just one, I can find out whether there is a path, right? Essentially, that's what I'm trying to do, right?
I mean, you don't have a guarantee that there's gonna be just one away. What if you have a thousand by thousand matrix, and then let's say at the very last corner it has a -1, and then the rest are zeros,
I see.
right?
So another way to do it is go to the -1,
Okay.
right? Take that index, and then basically update horizontal and vertical with
Okay.
that distance, right? And
Yep.
essentially then kind of like do the same, right? And do the same for each -1. Unless
So you're
unless
saying,
so what I'm saying is that, let's say you go from here, right? You find out -1,
yep.
right? You set the distance as saying that, okay, the distance index is 1, for example, right? And
Yep.
then essentially what you do is you go from horizontally and vertically, and you will
Yep.
update that row and column,
Right.
right?
So
So
would it
you
be just the row and column?
mm, so right now I'm thinking row and column, because I'm gonna do it for each -1.
Okay.
Let me try to. think about this. This is an interesting problem. Okay, so I was 0,
So
you're -1. Go ahead, sorry.
I think an example like this would probably be helpful for determining, whether it should be just like what you should update. What if there's only one -1, right? Like what we have on line 6 and 7.
Okay. So if you just have one -1, then you find that -1 and then okay, you update the vertical and the horizontal. I'm trying to understand the hint.
Well, after you update it, you'll have 1, 1, 2, but then you have some zeros left over, right?
Yeah, and okay. And essentially what you're saying is that then you go from there to that 0?
I'm saying you can't just update only the rows and columns, right? It seems like you want to
I see.
kind of expand outward.
I see. So essentially what you're saying is that, okay, the moment you hit a -1, for vertical and horizontal, you update the distance, right? But at the same time, each time you update that distance, right, you look at
Yep.
its own left and right, and basically if there is a 0, then you increment that distance and then you put that in, right?
Yeah,
Like
that does seem to be like the kind of thing that's happening here.
okay. So essentially, you go here, you update 1, and then you say, okay, do I have somebody around me who is a 0? And if there is, then you take your distance and then you add +1 to it, and you put the minimum of whatever is in there, right?
Right.
I see. Okay. That makes sense. Okay. So what would be the runtime? So that the runtime of that would be kind of like for each -1, and then for each vertical and horizontal, you are going and updating each element. Basically, each element which is around you. Oh no, actually, you know what? So for each -1, you are updating this, this, and the top one, if it is valid.
Okay.
Right? So and then for each of these elements, you are gonna run unless you return back to this element. Right? So once you hit this element, you're gonna update all of the cells around it. Right?
Okay.
And you can also optimize it better, but the way I'm thinking about it is, let's say if there was like a let's add, if I add, like, for example, another column right here, let's say
Yep.
0, 1, -2, 0, for example, right?
Okay.
So if I think about, like, actually, let's say this is a -1, right? So essentially, when I will come here, when I will expand it here, I will put 2 here, right?
Okay.
And once I put 2 here, I'm gonna look around and I'm gonna say, okay, is there a -1? Right? Sorry, like for each of my, like, if for each of my values or indexes which are around me, if
Yep.
there is a -1, right, then I'll update my index as 1, essentially.
That's
Right?
like really specific though, right? Like when does it stop? Do you stop updating when it turns out it's 2-way, it's 3-way, it's 4-way, right? Like that seems like you're mixing in two different approaches at once. One approach is expanding from the -1s, and then the other one is looking for -1,
Yeah,
while you're there. So I don't think you want to mix two of them together. That seems like it'll
yeah.
be more complicated.
No, I completely agree. The thing is that I was thinking about having about 2 heuristics to decrease the amount of iterations that you do, right? But I think
Okay.
what we can do is we can kind of like get started with this implementation, right? Like, is that
So sorry, I didn't catch the part where you determine the minimums. So earlier you mentioned that you're going to update the values if you find that the neighbors are zeros, right? But
yes?
let's say let's go back to the initial thing.
Yes.
Sorry, I don't remember what the actual. Okay, let's say it was this.
Okay.
Let's say you've done your initial traversal, right?
Yes.
From that top -1, so you have the 2 updated, right?
Yes.
When would you be updating this 2 to a 1?
So essentially, what I'm thinking of doing is I'm going to go through each of these -1s, right?
Got it.
And the moment I
Got
hit
it.
a -1, I'm gonna do the same. I'm gonna run the same algorithm again.
Okay. Yeah, that seems like that's an approach that works, and maybe we can talk about the complexity of that and how to improve it later on. But for getting code out, I
Uh-huh.
think we can go with that approach.
Okay. So okay. So essentially, instead of a of I being 0, it should be -1, right? And then what you will do essentially is you will you are cells around my current distance A, I, and J essentially, and then this function essentially should be what it is supposed to be doing is that if essentially I is valid, right? Like if I -1 is greater than 0, greater than equal to 0, and A of I is not equals to -1 or not equals to -2, then
Yep.
essentially you will update like you will call um, you will essentially a -1 j, and you're gonna do essentially like a +1 to the distance, right? Distance plus equals to distance +1,
Okay.
right? And essentially you're gonna do it for each of these, right? And then because you found this guy, you're gonna say, okay, update the cells around me, and you're
Right.
gonna just say distance +1 comma a comma. Actually, I don't need to pass distance, but mm, I like yeah.
What do you mean you wouldn't need to pass distance?
No, I was just thinking because I'm passing I and j, I
Okay.
can look at I and j value and then identify what is the distance of this cell from a -1, right?
Sure.
So I don't essentially need to pass a distance, but whatever, right? Um, so essentially, kind of like just a similar approach, right? Where you keep calling this recursively, but if I of j equals to -2, or if it is -1, then you return. Then you don't want to do anything, right? Essentially. So if the moment I come here and then I say, okay, okay, you're -1, so I'm not going to do anything. I'm just going to return back, right? And then you go to the left. Okay, you're so okay. Okay. Yeah. So if you go to the left and you say, okay, I'm a 0, and then you essentially update it to 1, and then you'll do the same thing again for this guy, right? So
Right.
this is sort of like the pseudocode that I'm thinking, right? Any so do you want me to start implementing the code, or do you want me to kind of
Yeah.
like go over?
Let's
Okay.
let's go ahead and write out some code.
Okay. Right, update. So I'm assuming that you're gonna be passing me a vector of a vector,
Yep. You can assume, yeah, that's vector int.
and you're gonna be passing me a, and then in distance.
There's no distance, right? It's just a vector. Oh, sorry. That was my mistake. I thought this was your main function, but this is update cells around. Yeah, that's fine.
Yeah, this is update cells around. Sorry about that. Right. So then let me so what that's okay. Um So this will be your find distance, for example, and essentially you're just going to be passing me the same thing,
Okay.
right? And what I'm going to do is I'm going to just copy this. Actually, you know what? No, it's okay. And I int j int len equals to a dot size int I length and jlen equals to ilen equals to 0 question mark. Let's see.
I think it's fair to assume you can assume that it's not an empty matrix.
Okay.
Yeah.
Then if 0 dot size I should be less than ilen I plus plus, and then the same thing here as well, except it should be j.
Okay.
Right, and then if a of I of j I, so again I'm not checking for input sanity.
Yep.
Right, so
Yeah, it's totally fine. You can assume that it's a valid input.
okay, yeah, exactly, right. I just wanted to like say the assumption out loud, right? Okay, cool. So essentially, okay, now let's say if a of I of j equals to -2, then you will just return, right?
Okay.
Now if I minus 1 is greater than equals to 0, and what do I want to do, right? Essentially, okay, no, I don't want to do microbus. So I minus 1 is greater than 0, and a of I is equals to 0, right? Because no, actually, you know what? No, is not equals to -1. -1 is of j is not equals to -1.
Okay.
So if it's -2, then I'm not going to do anything. So it should not be -1. And essentially what I do is I will just take this guy and then I will say plus equals to distance plus 1. Actually, I will do so you want minimum distance, right?
Yeah.
Or max? Okay, you want minimum
You
distance.
want the minimum.
So what I'm thinking is that if I just call like a min of distance plus 1 and then comma a of I minus 1 and of j, right? Then because
Okay.
essentially if it is 0, then I'm always going to get a 0, right?
Yeah.
And that's going to fall back my whole this thing, right? So the way I'm thinking about it is kind of like having a ternary operator where I'm saying if this is equals to 0, right, then update this thing, right? So if this is equals to 0, right? So if this is equals to 0, then put like a int max, otherwise return a of I minus 1 of j,
Sure.
right? And then because now I have updated this guy, so I'll just do the same thing again here. I will update the cells around and then I'll pass a and I'll pass the a of I minus 1 of j, and then I'm going to pass I and j. Actually, I'm going to pass I minus 1 and j, right? And then essentially I just the same thing again for like j and all that goes guys, right?
Right.
So let me try to think if I can do this in a better way, but I still need to update 0 1 minus 1 1
Yeah, it
Um,
seems like the whole update step can kind of be changed around.
yeah.
Like it doesn't have to be in every single one, right?
Mm, e- why not? It has to be in every single one, right?
Well, you only need to do it once per recursive call, right? Is kind of a way you could view it. Because if you're going to be updating before you make that recursive call, it's the same as making it at the next level of the recursive call, right? For
Um,
example, a of I minus 1 to j, if
mhm.
you call, update cells rounds of a I minus 1 to j, that's the same thing as just doing that step in the next recursive call. Like you'll have the exact same set of information that you'll need to make that decision, right?
So when you say next recursive call, that is,
So let's say the update is done on line 51, the next recursive call is line 52, right? Uh,
yes.
and you should have all of the same information if you wanted to, shorten it.
So essentially, okay. I'm trying to understand this. So you're saying that I can club this in this, or
Well, all of the updates on the distance, right?
hmm
Uh, the logic for the most part is the exact same. Even though you're updating, well, I mean,
ah, I see
I
your
imagine
point.
you're going to be, I imagine you're going to be updating these so that it's not I minus one, maybe it's I plus one, right? But for the most part, you can just, like, I imagine if you have A of I
No,
of J,
I
it's the
see.
same
No, no.
thing.
I think what you're saying is that in at line 48, what I can do is I can check whether a of I and a of j is not equals to minus one, right? And then based on basically a of I and a of j, I can update that distance of a of I and a of j, right? So
Yeah.
you will essentially do it just once per call. You don't have to do it again and again, essentially, right? Like
Sort
something,
of, yeah.
right? Something like if a of I and a of j is not equals to um, minus one, then update the value, right? Essentially, like something like this, right? Essentially, like something like this, right?
Uh, yeah, like,
So
I imagine you'd have to change it up a bit, but yeah.
yeah, yeah, I'm just trying to think, right? You come in here and then you'll be like, okay, if I'm not minus one, okay, update the minimum distance or something, right? I understand that I might have to update it a bit, right? So essentially, essentially here what I'm doing is I'm taking the ij, which is minus one, right? So I
Okay.
will come in here and I will be like, okay, I'm not minus two, so I'm minus one, so I'm not gonna update my distance, right? And then
Okay.
essentially I go in here and I will say, okay, update the cells around, and here I have this as a minus one and j. It should be distance plus one, right?
Okay.
So then when I come here for minus one j, like I is I minus one and j, right? I come in here and I say, okay, it's not minus one, so I will take the distance and then I'll add one to it, right? So that way I just have to do it once, right? Okay, I see your point.
Right.
Okay, cool. So then it's again essentially, right? This is just the same thing, right? J minus one, if j minus one is greater than zero, and I of j minus one. Actually, I don't even need to do this check because
Okay.
I'm already doing that here, right?
Right.
So should be fine. Let me remove this here. Right. Okay, we have very less time. Mm, j minus one. And then this guy is gonna be j minus one, and then same thing again here. Okay, wait, I can just remove this. Why am I putting this in?
Right.
Uh, j minus one, and then j minus one, right? And then essentially the same thing. Oops.
Okay.
Right, essentially the same thing here, that you're gonna check I plus 1 is less than, so I can pass this thing, right, the a size and all that stuff as well, right? So I can pass int ilen comma int jlen.
Right.
Right, so here I can check if I plus 1 is less than ilen and just pass I plus 1 and then j and then I plus 1 and j, and essentially like the same thing here where I'm gonna say plus 1 less than jlen, and then update the less around plus 1 and then do another plus 1, right?
Sure.
Okay, and then put a return here. Okay, so let's just quickly walk over this, right? So I come in here and I check each time if it's -1,
Okay.
go and update the information. So if you're -1, you're not gonna get updated. So you're still gonna be -1, right? So you're gonna come in here, you're gonna go to the left, and not to the left actually, it's I -1. So you're gonna go up essentially. If I -1 is greater than 0,
Yep.
and then you're gonna come in here and then you will go back in and then you'll be like, okay, it's not 2, it's not, if it's not -1, then okay, you're gonna come in here, you'll say, okay, 0 plus 1 is 1, and then because you're already 0 right now, if you'll be integer max, so then you will update this a of I and a of j, right? And then you will again check, okay, this is not valid, and then you will be like, okay, you'll go down to the j and so on. So this is like exponential essentially, because each time you're going to come in here and if I and j is not like -2 or something, then you're just going to call the update cells around again and again.
Yeah. So one thing to point out is you will be visiting cells again, right? Because it seems like as soon as you have one recursive call, you'll be going back to the previous one, and this doesn't terminate. So how can we fix that?
I see. So essentially, the overall idea is that you do not want to visit a cell which already has been visited.
Yeah.
I see. How can I do that? 0. So I just need to have a way to update that, hey, this cell has been visited, right?
Yep.
Now either what I can do, no.
We can just keep track of that somewhere, right?
I can have another vector of a vector where I can say, hey, whether this ij has been visited for this iteration, right? So that way you can keep track of in which iteration you have visited which nodes.
Right.
Right. That is one way to do it. But that way you will be using more space. Right. So you'll be using the same amount of space that the vector has.
Right. Yeah. So using some additional space is probably totally okay. So that is an option.
Yeah, no, yeah. Another option that I was thinking was that in the A itself, you can specify certain bits to say, hey, whether this has been visited or not. But then that is going to limit your maximum number of elements that you can reach. Right? Like
I'm not following on the bits.
No. So for example, like let's say you have like 8 bits, right? So like you'll have 0, 0, 0, and then when you're 1, you're essentially this.
Okay.
Right? And when you're -1, then essentially you'll be like negation of it and then +1 and so on, right? Actually, no, that won't work. My mistake. Yeah, that won't work because it is an integer, not a ulong. So, okay.
Yeah, I think using an extra matrix or a map, either of those are totally okay.
Yeah, let's go with a vector, right? Because that way kind of like, because we are already using a vector.
Sure.
So flags, right? Okay, and then or if flags of I of j is equals to true, then you will return essentially, right? And each time you update the value of this cell, I'm gonna say, hey, flags of I of j is false, right? So each time, so the first time I come in here, actually, you know what? No, this should not be here. This should be here, because even for the -1, I want to say, hey, this has been visited, right? So that you don't go back again, right?
Right.
So you will set this as false, and then you're gonna say, okay, if flags of I of j, actually no, this should be true. My mistake. Sorry. So if I set the flags of I and j as true, right? And then this flag should be passed together. So this should be a pass by reference, not pass by value, because I want the values to persist.
Okay.
Right. Let me think about that. Flags of I and j. So I want this flags of I and j to be true. So yeah, so we can do that, right? So we can have like the flags here in the call itself,
Sure.
right? And here essentially what I can do is I can have like a vector pool, oops, and then I can just say a flag, and then I'll just say I want it to be like ilen comma jlen. So I know that this is not the correct format, right? But what I'm trying to say is that have the flag where I'm initiating this as ilen and ij, and then setting everything to false.
Right. I think that may actually be the correct way for initializing.
Yeah. So I
That
have
seems about fair. Like
yeah.
the
So I
island and
have.
the jlen might be backwards, but other than that,
Oh, I see. Yeah, I have initialized vectors, but like a single D vector, not a 2D vector. So that's why I'm kind of confused about that. But I see your point. So in
right.
that case, then let's just switch it up, right?
Yeah, I don't know which way it goes, but I mean, we can do it by an n by n matrix, if anything, and then it won't matter.
Yeah, I see. Yeah. Actually, we can even do it by an array, right? Because now you know what is your ilen and jlen. So, but yeah. Okay, so here you will call the update cells around, and then you're gonna set the flags of I and j as true, and essentially you're passing it by. Actually, I don't want to pass it by value, right? Or do I want the
Right.
values to persist? That's the question that I'm trying to answer right now, right? So the moment I come in the first time, I think I do want the values to persist.
Yeah, it seems like you only want to reset them when you're starting your
Once,
new round of search, right?
yeah, exactly, right? So here I would need to kind of like just sort of like initialize flag, sort of like a thingy here, right?
Right.
And then this is a vector, right? If it was array, then I could just like do like a mem set or something to set everything to like 0, right? But again, this will be m plus n operation.
Right.
Right. So here you will initialize the flags, right? And then so I can put in two for loops to initialize it, right? But yeah, I think you understand what I'm trying to say, I guess. So
Yeah.
okay. Anything else that I'm missing here?
Well, I mean, there's definitely some bugs in the code, and maybe you could probably find it with test cases. But given the time, maybe you can try and reason through it.
Yeah, okay. So let's talk about it, right? So we're not going to talk about the edge cases of nothing in the array and all that stuff, right? So
Yeah.
so if let's say if everything is -1, then what happens? So if everything is -1, you're going to come in here. Each time you're going to set the flags of I and j to true, right? And because you will set the flags in I and j to true, you are gonna make sure that nothing. Basically, you will there will be a point where you will terminate here. That
Okay.
essentially, um, for let's talk about
Just think of like a normal case, right? Like a generic case of you have the thing from above. Let's just say there's a -1, 0, 2, 0, followed by a 0, 0, -1, 0, something simple like that.
Okay, so if that is the case, then so you go here and then you will come in here and then you'll essentially what you will say is for the first time you come in here you'll be at here and your distance will be 0 essentially, and then you will be here and then you will come and you
Wait,
will set
sorry.
this.
This thing here, I don't think I can see what you're highlighting.
Oh, no, sorry, my mistake. Yeah, so on the line 344, right? So
Yep.
the first time you come in here you set this to true, right? That okay, I have
Okay.
visited this node. Then you check on the on the top, no cell is there, right? And then you will come on the left, which is there, so there is no cell, right? Then you will
Yep.
go down, right?
Right.
And because when you go down, essentially, what you will have is so you will be and at line 78, right?
Yep.
You will where did the distance go? Oh, interesting.
Yeah, that's like one of the things that's missing from a bunch of lines, right?
Yeah, my mistake. Sorry.
Yep.
And I think we are also we're also missing flags. I think are
Yep.
we are right. And then, okay, so flags, distance, ij, and then the island and this thing, right? Uh, right, and then island, jln, and then essentially the island and jln should be called here, right?
Right. Yeah, just because that was
Uh,
added.
yeah, I think that yeah. Pardon, can you say?
Yeah, no, you can continue.
Yeah, no. I understand that there can be a better way where I can like instead of passing ILN and JLN through each call, I can set it up sort of in the class itself,
Okay.
so that I don't have to call this ILN and IJ again, right? You can the moment you call the constructor, I can set the ILN and JLN, and then you keep reusing it. So I don't even need to sort of like to do that here, but yeah. And so you come in here and then you will check whether I can go down. And because you can go down, you will come in here and then you'll be like, okay, it's not -2. The flag is
Yep.
not true. So you will go and you will update this distance to 1, right? Sorry, you will update this distance to 1 at line 44, and then in 44 you'll go in and you will set in true, right?
Yep.
And then you will set in true, and then you will again go essentially saying that okay, um is wait yeah, essentially, so you're gonna come here and you will be like essentially okay, is the can I go to the top, right? So when you go to the top you'll be like okay, flags of I and j is true, so you'll return back. Then you will be like okay, can I go on the left? You cannot. Then you will be like okay, can I go down? You cannot. And then you will be like okay, can I go right? And then you will be like okay, I can go right. So you will come in here and you will be like okay, af I of j is not -1. So I'm going to take whatever here is, and then I'm going to add +1 to it essentially. And then I'll set this to true, and I will set this as 2, right?
Right.
Okay, I see. So essentially, okay, no, that's fine, right? Yeah. But just give me 1 second, right? Wait 1 second. Okay. So then essentially, you will for this guy you will go top. You'll ask for top, and then you'll be like, okay, I can go to top, and then you are gonna update this guy instead of 1, you're gonna update it to 3, right? And then you will set this to true, so that nobody essentially can ever go there. I see. So
Wait, I'm
uh
sorry. Oh, okay, you're still on the first recursive call of that.
yeah.
Right. Okay. Because by the time I imagine that this finishes, that should still end up being a one, right?
Exactly, right. And that's what I did wrong here. I'm passing the pass by reference. So this should be passed by value actually. So that way, each time, so here you have set it to true, right? Now, essentially, this is two. This is already visited. You cannot go up, and you have already visited down, right? So here you will essentially start going back, and then you will, because you're passing by this thing, you will essentially set this to false, that to false, this to false, right? And essentially, you have traversed this guy here,
Right.
right? And then then you go essentially to the next one here, right? Which is should be 0, but it is 3, right? So and then when you go here, because that was the last call, right? You will go here, and then you will be like, okay, if a
I've
of
already
I of j,
gone there right now.
pardon?
Sorry, continue. Yeah, you can continue. I was just like agreeing with you.
Oh, okay. Yeah. So and then you will just update this to 1, and then set this to true, right?
Right.
Actually, you know what?
I'm not sure how this ends up changing with the value. So when you pass by value inside of C++, that's the equivalent of passing by assignment, right? In the sense that any updates to the flags will only exist on this specific call stack, right? So as soon as you recurse, those updates no longer exist.
Yeah.
But
No,
when
no.
you pass
So
down to
let me.
deeper recursive calls, those updates do exist.
Yeah, they do exist. Yeah,
Got it.
yeah. So
Okay. I guess
actually,
given the time, actually, we're gonna have to kind of end it on that.
yeah.
So one thing I actually wanted to talk about is, do you think, the approach that you ended up taking is actually similar to running DFS on
Yeah.
the cells, right? Is there any way
Yes.
we could kind of improve that? We didn't really talk about it, but there are alternatives. It seems like you're going out and you're just going as far as you can. Um, is there a different way of traversing the matrix that we can take?
I'm trying to think about the graph algorithms, right? I'm trying to think if some sort of like a topological sort, or something in which you align all these elements basically in sort of like a distance order or something.
Yeah, like you kind of right in a distance order in the sense that you'd be starting from the one and you'd be going out to the nearest items first, right? And then you'd go to the next nearest items, at the next nearest, and so on.
Hmm.
So of the common graph algorithms, is there one that kind of fits that criteria?
You're talking about like BFS or something?
Yeah, like I
Because
think.
in
Uh, Go ahead.
no, sorry, but because in BFS, what you do is you take the node, and then you push all the nodes around, and then you kind of like go and process each of them.
Yeah, in a queue and whatnot.
Exactly,
So
right? Yeah.
when you end up doing that, I think you can avoid reprocessing from each of the ones. This isn't really required for this problem, but this is just kind of like if you want it, you can solve it this way. It ends up
Oh, I
bringing
see.
So the complexity you end up getting when you decide to run DFS is every single time you see a -1, you have to visit all n by m cells, right? In worst case.
Exactly. Yes, in the worst case, yes.
And so you'd be doing that for each -1. The only improvement that using BFS makes is that instead of revisiting the entire thing, say g times, where g is the number of -1s, you would just have n times m, because you can just put
Oh,
all of the
interesting.
-1s onto the queue. Yeah, that's not really required, but it is an improvement. I think
So
the
let
one
me
thing
try to.
sorry.
Go ahead. Sorry.
I was
No,
gonna
no,
say
go
I
ahead.
think the one thing it fixes is the problem that you had where you were getting that 3 instead of a 1, because the order that
Yeah,
you'll visit items is going to guarantee that the nearest items are always visited first. So it's really easy to keep track of visited flags and things like that.
I see. So okay, if I try to understand this right, then in BFS, what you're going to do is you're going to look at this -1, and then you'll be like, okay, push one, right? And then you're
Uh,
going to take this and then you're going to process it.
yeah, so let's say at the bottom you have your
I
queue, right?
see.
So you have your queue, you're gonna have
I see.
I, J, and then depth, right? Or distance, if
Oh,
we were to use the same
okay.
term. And
Yes.
you would have this, your initial queue would be all IJs where the -1s exist. And so all you have to
I see.
do is just process until the queue is empty.
No, no, I see your point. It's essentially BFS, right? I see. Yeah. No, so yeah, it's essentially BFS, and that's interesting approach. Yeah. Yeah.
Yeah.
I see.
Normally, I think the only reason that it would have helped with your own is just to avoid this bug. But I guess the
Of
code might be
yeah.
similar. Cool.
Oh
I
yes,
guess,
for sure. Yeah.
right. With that, did you have any questions for me?